In 2000, scientists sought to date what they believed to be the oldest star in the universe. They estimated that HD 140283, or Methuselah as it is known, was 16 billion years old. The analyses were carried out by the European Space Agency's ESA Hipparcos satellite. However, this confirmation seemed puzzling as the age of the universe, determined from observations of the cosmic background radiation, is 13.8 billion years. So how can a star be older than the universe? It was a serious discrepancy, said astronomer Howard Bond from Pennsylvania State University in an interview with Space Portal. Based on this information, researchers began to unravel the truth and test the accuracy of the figure. Their conclusions were equally surprising. Astronomers have been observing the Methuselah star for over 100 years. It is located about 190 light-years from Earth in the constellation of Libra and travels quickly across the sky at 1.3 million kilometers per hour. It became clear that the star was old. The metal-poor subgiant is predominantly composed of hydrogen and helium and contains very little iron. This composition means that the star must have formed when helium and hydrogen dominated the universe and before iron became common. Heavier elements only appeared when massive stars created them in their cores. Could Methuselah really be over 2 billion years older than its environment? Certainly, this is not possible. Either the star was older than the universe or the universe was not as young as scientists thought it was. A mystery of such magnitude could not be ignored, so astronomer Howard Bond and his colleagues tried to uncover the truth by analyzing 11 sets of observations recorded between 2003 and 2011. These observations were made by the fine guidance sensors of the Hubble Space Telescope, which recorded the positions, distances, and energy output of the stars. By acquiring parallax measurements, spectroscopy, and photometry, the scientists were able to gain a better understanding of the star's age. One of the uncertainties with the age of HD 140283 was the precise distance of the star, Bond said to Space. It was important to get that right because we can better determine its luminosity and, from that, its age. The brighter the intrinsic luminosity, the younger the star. We were looking for the parallax effect, which meant we were seeing the star with a 6-month interval to look for the change in its position due to the Earth's orbital motion, which tells us the distance. Bond added that there were also uncertainties in the theoretical modeling of the stars, such as the exact rates of nuclear reactions in the core and the importance of elements diffusing in the outer layers. So, they worked on the idea that the remaining helium diffuses deeper into the core, leaving less hydrogen to burn through nuclear fusion. With the fuel used up faster, the age is reduced. Another important factor was, of all things, the amount of oxygen in the star, Bond said in an interview. In the end, the star HD 140283 had a higher oxygen-iron ratio than predicted, and since oxygen was not abundant in the universe for a few million years, it pointed again to a lower age for the star. As a result of all this work, Bond and his collaborators estimated the age of HD 140283 at 14.46 billion years. It was a significant reduction from the previously claimed 16 billion, but still older than the age of the universe itself. In that sense, it did not clarify the puzzle and apparently simply ensured that Methuselah remained a mystery. But the scientists presented a residual uncertainty of 800 million years, which Bond said made the age of the star compatible with the age of the universe. It was a major breakthrough. It was a serious discrepancy, says astronomer Howard Bond from Pennsylvania State University. So, with that in mind, Bond and his colleagues started to uncover the truth and test the accuracy of the figure. Their conclusions were equally astonishing. Astronomers have been observing Methuselah, named in reference to a biblical patriarch who supposedly lived for 969 years, making him the oldest biblical figure for over 100 years. This curious star is located about 190 light-years away from Earth in the Libra constellation and travels quickly across the sky at 800,000 miles per hour, 1.3 million kilometers per hour. It became clear that the star was old. The metal-poor subgiant is predominantly made of hydrogen and helium and contains very little iron. This composition suggests that the star should have formed when helium and hydrogen dominated the universe and before iron became common. Heavier elements only appeared when massive stars created them in their cores. But could Methuselah really be over 2 billion years older than its environment? Surely that's not possible. Either the star should be older than the universe, or the universe shouldn't be as young as scientists thought. Or maybe that relationship was simply wrong. But what could be making the universe potentially appear younger than this particular star? There are two options, and the history of science suggests that in these cases, reality is a mix of both, Matthews said. In this case, there are observational error sources that haven't been fully understood, along with some gaps in the theory of universe dynamics, like the strength of dark energy, which has been the primary driver of cosmic expansion for many billions of years now. He suggests the possibility that the current age paradox reflects the variation of time in dark energy and, therefore, a change in the rate of acceleration. A possibility that theorists have found to be compatible with ideas about the fundamental nature of gravity, such as the so-called causal set theory. New research on gravitational waves may help resolve the paradox, Matthews said. To do this, scientists would observe ripples in the fabric of space and time created by pairs of dead stars, instead of relying on the cosmic microwave background or monitoring nearby objects like Cepheid variables and supernovas to measure the Hubble constant, the former resulting in a speed of 67 kilometers per second per megaparsec and the latter on 73. The issue is that measuring gravitational waves is not an easy task, as they were only detected directly for the first time in 2015. But, according to Stephen Feeney, an astrophysicist at the Flatiron Institute in New York, a breakthrough could be made in the next decade. The idea is to collect data from collisions between pairs of neutron stars using the visible light these events emit to discover the speed at which they are moving relative to Earth. It also involves analyzing the resulting gravitational waves for a sense of distance, which can combine to provide a measurement of the Hubble constant that should be the most accurate to date. The mystery of HD 140,283's age is leading to something bigger and scientifically more complex, altering the understanding of how the universe operates. The ages of stars are generally estimated based on their brightness or composition, with the oldest ones being richer in helium and hydrogen. To find out how long ago the Methuselah star formed, in 2013 researchers used data collected by the Hubble Space Telescope and estimated that it is around 14.6 billion years old, potentially with 800 million years more or less. As for the date of the Big Bang, it was determined based on the rate of universe expansion predicted by Einstein's general theory of relativity at 13.79 billion years. However, these calculations have now been questioned due to evidence pointing to the existence of stars older than that, or so close that there hasn't been enough time for them to form. Suggesting that the Big Bang never happened because of this would be a revolution in science and would change everything we currently know about the cosmos. Less radical yet still dramatic hypotheses suggest that the universe emerged 26.7 billion years ago. If that were the case, we would have already found at least some stars around 20 billion years old. The most modest hypothesis is that it would have emerged around 15 billion years ago, but for that, some of our calculations must have been wrong about the universe's expansion. Unveiling the mysteries of the universe, are we on the brink of a cosmic revolution? Explore the latest theories challenging our understanding of the universe's origins and the age of stars. Could the Big Bang be in question? Join us on this mind-bending journey through space and time.